The technical coding interview. For a lot of us, it is the single most intimidating part of the entire job hunt. It can feel like you have to know absolutely everything. But what if I told you there's a pattern? What if a small, core set of problems shows up over and over and over again? While the source material for this explainer makes a pretty bold claim, a massive 80% of coding interview rounds are covered by just 15 foundational problems. No, that is not a typo, 80%. And that one number, it completely changes the game from I have to learn everything to I need to master the essentials. And yeah, the source is really direct about this, and it's a powerful idea. Look, this isn't about finding some magic shortcut. It's about focusing your energy where it's going to have the most impact. When you master these problems, you build the foundational logic that helps you solve almost anything an interviewer can throw at you. So that's exactly what we're going to do in this explainer. We are going to walk through that core list. We'll break down not just what the problems are, but the patterns behind them. Think of this as your roadmap to conquering that 80%. So, first things first, we're starting with the absolute fundamentals, strings and arrays. These are literally the building blocks of almost every complex problem out there, and interviewers love to use them to get a quick read on your core programming skills. First up on the list, reverse a string. It sounds almost too simple, right? But believe me, it's not a trick question. An interviewer is just trying to check one thing. Are you comfortable with the basics? Can you manipulate data? Can you loop through it? It's the warm-up lap before the real race. And right away, this leads to a perfect example of a key interview pattern. Checking if a string is a palindrome, the same forwards and backwards, is really just about reversing a string and then comparing it to the original. You see, the exact same logic gets recycled. Learning to spot these patterns is absolutely crucial. Okay, finding duplicates. This is where we introduce a super important pattern, the scene set. The most efficient solution uses what's called a hash set. Think of it like a magical bag where you can ask, hey, is this thing already in here? And get an answer instantly. As you loop through the string, you just keep adding characters to the set. The moment you find one that's already there, boom, you've found a duplicate. This pattern is a lifesaver. Now, this one can look a little scary, but Kadane's algorithm is surprisingly elegant. The big idea is to walk through the array while keeping track of two numbers, the best possible sum ending at your current spot and the best sum you found anywhere so far. You can see it in the table here. Current max goes up, it goes down, but max so far, that's your high score. It only ever changes if we beat the previous record. It's a brilliant way to solve this in just one go. Okay, next section. Let's talk about numbers. These problems are all about testing your logical thinking and really your ability to write code that's not just correct, but also efficient. So checking if a number is prime seems easy, right? I mean, you just check if it's divisible by other numbers. But the real test here is about optimization. Just looping through every number is way too slow. The interviewer wants to see if you know the trick. You only need to check for divisors up to the square root of the number. It's a classic test of efficiency. Fibonacci and factorial. These two are practically a rite of passage in computer science. They are the absolute go-to problems for testing if you understand recursion, a function that calls itself. But they're also a great chance to show you understand the trade-offs and that you can solve them another way, maybe iteratively, to avoid some of the performance problems that recursion can cause. All right, time to level up. This next set of problems requires you to organize your data in very specific ways to solve them efficiently. We're moving into the world of linked lists and trees. Reversing a linked list can seriously feel like brain surgery, but it's really just a careful dance with pointers. The absolute number one most important thing is step one. You have to save the next node in a temporary spot before you change anything. If you don't, you'll lose the entire rest of the list. Once you've done that, you can safely reverse the pointer and then just step down the line, doing it all over again. This is one of my personal favorites because the solution is just so clever. It's often called the tortoise and the hare algorithm. You have a slow pointer moving one step at a time and a fast pointer moving two steps. Now, if there's no loop, The fast one just runs off the end. But if there is a cycle, that fast pointer will eventually come around from behind and lap the slow one. They are guaranteed to meet. It's simple, visual, and just incredibly effective.
Tree traversals can sound really intimidating, with all these names like in-order, pre-order, post-order, but honestly, they are just simple, repeatable patterns. For in-order traversal, which is super common, the pattern never ever changes. You always go left, then you visit the node you're on, then you go right. Left, root, right. That's it. You master that one pattern, and the others just click into place.
So what does it even mean for a binary tree to be balanced? The rule is pretty simple. But here's the catch. It has to apply everywhere. For every single node in the whole tree, the height of its left side and its right side can't be different by more than 1. And that means the solution is naturally recursive. You check the left, you check the right, and then you check the node you're currently on, all the way back up the tree. All right, welcome to the final section, the final boss problems. Now, these aren't necessarily harder, but they often require you to combine concepts from the previous sections. They're all about testing your ability to pick the right tool, the right data structure or algorithm for the job. To-sum is, without a doubt, one of the most famous interview questions of all time. The obvious way to solve it is slow, but the elegant way uses a hash map. It's like having an assistant. As you go through the array, you show each number to your assistant. For each new number, you first ask, hey, have you already seen the other number I need to reach my target? And your assistant, the hash map, can answer that question instantly. Our next two problems really highlight how a clever setup is half the battle. For merge intervals, the absolute key is to sort the intervals first. Once they're in order, the logic to actually merge them becomes surprisingly simple. And for finding the missing number, the trick is often mathematical. You can use a formula to figure out what the sum should be and then subtract what it actually is. Both problems show that preparing your data correctly can make a hard problem easy. And finally, we have a bit of a system design problem, the LRU cache. LRU stands for least recently used. Think about your web browser's cache. It can't store every single website you've ever visited, right? So when it gets full, it has to kick something out. And LRU cache always kicks out the thing you haven't touched in the longest time. So how does it do this efficiently? When you add a new item and the cache is full, you have to kick out the oldest one and then add the new one as the newest. The classic solution is a beautiful combination of two data structures, a hash map for instant lookups and a doubly linked list to quickly move items to the most recent position. It's the perfect team-up of speed and order. So what's the big takeaway here? The goal isn't to just memorize these 15 solutions. It's to deeply understand the underlying patterns. Things like the scene set, the two-pointer technique, recursive thinking, using hash maps for instant lookups. These are the real tools. These 15 problems, they're just your training ground. So we've laid out the map that covers 80% of the territory. The journey from feeling intimidated to feeling confident starts with just one step. So looking at this list, what's the question you should be asking yourself? It's this: which pattern, which one of these core ideas are you going to tackle and truly master first?